At the core of many diesel engines lies the injection pump. A reliable injection pump ensures consistent fuel delivery, precise timing, and efficient combustion. When the pump begins to degrade, performance suffers, irregular idling, loss of power, smoke issues, or difficulty starting. Today we explore in depth the J926887 pump, which is compatible with a variety of case machines, including models 2555, 2155, 2188, 420, MX200, MX220, CPX420. The aim is to guide through compatibility, inspection, installation, bleeding, testing, and field verification. A purchase link is placed in the description for convenience, but always confirm compatibility before ordering. First, consider why replacement becomes necessary. Over time, wear and tear erode internal tolerances. Plungers, sleeves, delivery valves, seals, all begin to drift. When tolerances loosen, pressure can drop, leakage can increase, and timing may shift. This leads to symptoms such as rough idle, hesitation under load, or increased smoke. At that stage, repairing may be uneconomical, and a replacement pump like the J926887 becomes desirable. Compatibility is more than matching part numbers. While this pump is designed for case 2555, 2155, 2188, 420, MX200, MX220, CPX420, verifying that the internal specifications, mechanical interfaces, and performance curves align is essential. Engines sometimes have subvariants or changes over years. The same model label doesn't always guarantee identical injection systems. Inside the pump, every micrometer matters. The plungers and sleeves must maintain tight radial clearances. Delivery valves must respond cleanly. Return springs should remain consistent. All sealing surfaces must be perfect. Material quality matters. Hardened steel, polished surfaces, proper heat treatments all contribute to longevity. Lower quality units might emit these and degrade quickly. One critical parameter is the flow versus pressure characteristic. A pump must deliver the necessary fuel at various engine speeds while maintaining stable pressure under demand. If the pump cannot match the required flow at high RPM, the engine starves. If over-delivering, the excess fuel may cause smoke or flooding. Therefore, before installing, check the spec sheet for flow, for example cc per minute, and pressure, bar or psi, and compare with the original pump or manufacturer specs. Another crucial matching factor is the drive interface. The drive shaft coupling must match in spline count, engagement depth, seal face alignment, and overall length. Even a small mismatch in spline or seal height offset can lead to failure. The mounting flange, bolt pattern, and alignment must also match exactly. Once the pump arrives, inspect before installing. Rotate its drive shaft manually to feel for smooth operation, minimal play, no binding. Examine all ports, check that seals or O-rings are properly seated, check for machining burrs or defects. If shipped dry, pre-fill or prime is needed, if the design requires it. Ensuring the unit is in ideal condition before mounting reduces chances of faults later. During mounting, use the correct gasket or O-ring. Align timing marks properly, if applicable, with the engine's drive system. Torque mounting bolts to the exact values specified. Misalignment or uneven torque leads to leaks or timing error. Connect fuel lines, return lines, and any bleed ports, making sure hoses are not kinked and paths are clean. Bleeding air from the fuel system is non-negotiable. Air in a diesel system causes compressibility, which disrupts pressure control. Use priming levers, bleed screws, vacuum bleed tools or whatever the system allows, and continue until fuel flows without bubbles. Crank, without ignition, to push fuel through the system and purge air. Perform repeated bleeding until the system is fully primed. Start the engine carefully. It should catch and run smoothly, with steady idle. Watch for white smoke, indicating